Hello. In this video, I am going to be discuss about chemical vapor deposition, thin film growth phenomena, and preparation of ceramic powders. So, chemical vapor deposition (CVD) is a process where one or more volatile precursors are transported via the vapor phase to the reaction chamber where they decompose on a heated substrate. CVD is a chemical process used to produce high purity, high performance solid materials. This technique is suitable for the manufacture of coatings, powders, fibers, and monolithic components. This technique is often used in many thin film applications by varying the experimental conditions, substrate material, substrate temperature, composition of the reaction gas mixture, total pressure gas flows, etc. Materials with different properties can be grown. Many materials may be deposited using CVD and related techniques. Metals, oxides, sulfides, nitrides, phosphates, arsenides, carbides, borides, silicides, etc. CVD was first used for hard coatings, for cutter tools, etc. Microelectronics, 3D structures, glass, solar cells, catalysts, membranes, waveguides, mirrors, synthetic gold. Now you can see here the process of CVD. Classified by operating pressure. Atmospheric pressure CVD, that is known as APCVD, where CVD at atmospheric pressure. Low pressure CVD, that is known as LPCVD. CVD at sub-atmospheric pressures. Ultrasonic vacuum CVD, UHV CVD at very low pressures, below 10 s to minus 6 pascals or 10 s to minus 8 torr. Classified by physical characteristics of vapor. Aerosol assisted CVD, AACVD, that is CVD in which the precursors are transported to the substrate by means of a liquid gas aerosol which can be generated ultrasonically. Direct liquid injection CVD, that is DLI-CVD, CVD in which the precursors are in liquid form, liquid or solid dissolved in a convenient solvent. Liquid solutions are injected in a vaporization chamber towards injectors. The precursors vapors are then transported to the substrate at a classical CVD. Plasma method. Microwave plasma assisted CVD, that is MPCVD. Plasma enhanced CVD, PECVD, that CVD that utilize plasma to enhance chemical reaction rates of the precursors. Remote plasma enhanced CVD, that is RPECVD, similar to PECVD except that the wafer substrate is not directly in the plasma discharge region. CVD, ALCVD, combustion chamber vapor deposition CCVD, hot filament CVD, that is HFCVD. And last, application of CVD in semiconductor and microelectronic industries. It is used in metallurgical coating industries, in optical fibers for telecommunications, and wear resistant coatings, corrosion resistance coating, and heat resistance coating, etc. Now, preparation of ceramic powders. Ceramic powders have been prepared by freeze drying, in which Multi-component liquid solutions are sprayed into a cold liquid to freeze the droplets, which are then separated from the liquid and subsequently sublimed. The basic steps include raw materials procurement, beneficiation, mixing, forming, green machining, drying, pre-sinter, thermal processing, glazing, firing, final processing, and packaging. There are three main types of potteries or ceramic. These are earthenware, stoneware, and porcelain. The powder metallurgy press and sinter process generally consists of three basic steps, that is powder blending or pulverization, die compaction, and sintering. Ceramic are typically produced by the application of heat upon processed clays and other natural raw materials to form a rigid product. After the particles are formed, these green ceramics undergo a heat treatment called firing or sintering to produce a rigid finished product. Traditional ceramic raw materials include clay minerals such as kaolinite, whereas more recent materials include aluminum oxide, more commonly known as alumina. The modern ceramic materials, which are classified as advanced ceramics, include silicon carbide and tungsten carbide. Ceramics are more than pottery and dishes. Clay, bricks, tiles, glass, and cement are probably the best known examples. Ceramic materials are used in electronics because, depending on their composition, they may be semiconducting, superconducting, ferroelectric, or an insulator. Ceramic powder is a traditional ingredient in building and plastering mortars. It is produced by crushing natural bricks and is baked at temperature of up to 900 degrees centigrade to give it pozzolanic properties. Dry pressing is the axial compaction of loosely granulated dry ceramic powders less than 3% free moisture within a die and punch arrangement. The powder under pressure conforms to the specific shape of the punch faces and die. Powder compaction occurs within a rigid walled die and usually between a top and bottom punch. So mechanical methods of producing ceramic powders. It's first ball mill, second roller mill, and third one impact grinding processes. These are the constituents which are present in ceramic powder percentage by mass. Silicon dioxide 66.57%, aluminum oxide, iron oxide, calcium oxide, sodium oxide, potassium oxide, and zirconium oxide. So these are the percentage of constituents in ceramic powders. Thank you very much for watching this.